actually don't know Britney Spears that well. I mean, her songs. But, Steven, you should give her a chance. I think they still make her perform in Vegas. They still make her perform? What do you mean? Who's making her who's making this poor girl perform? She should not perform if she doesn't want to. You know, you can accept more than one famous relative. Don't be so harsh on Britney. Okay. So, for 50 years, this approach has not been quite as blissful as ignorance, as in the people who don't work with each other, ignoring the small physics people, ignoring the large physics people, and vice versa. But it has been pretty close. So it's sort of a way to ignore the reality, which is that the two things don't really agree. And what's the flaw of that? My name is Baikal Sreshtha. Hello, Baikal. How are you? Felipe, hello. Felipe, can you please like the live? Can we get 20 likes? But the universe can be extreme. In the central depths of a black hole, an enormous mass is crushed to a minuscule size. At the moment of the Big Bang, the whole of the universe erupted from a microscopic nugget whose size makes a grain of sand look colossal. There are realms that are tiny and yet incredibly massive, therefore requiring that both quantum mechanics and general relativity simultaneously be brought to bear. For reasons that will become increasingly clear as we proceed, the equations of general relativity and quantum mechanics, when combined, begin to shake, rattle, and gush with steam like a red-lined automobile. Put less figuratively, well-posed physical questions elicit nonsensical answers from the unhappy amalgam of these two theories. Even if you're willing to keep the deep interior of a black hole and the beginning of the universe shrouded in mystery, you can't help feeling that the hostility between quantum mechanics and general relativity cries out for a deeper level of understanding. Can it really be that the universe at its most fundamental level is divided, requiring one set of laws when things are large and a different incompatible set when things are small? Superstring theory, a young upstart compared with the venerable edifices of quantum mechanics and general relativity, answers with a resounding no. Intense research over the past decade by physicists and mathematicians around the world has revealed that this new approach to describing matter at its most fundamental level resolves the tension between general relativity and quantum mechanics. In fact, superstring theory shows more. Within this new framework, general relativity and quantum mechanics require one another. Wow! Requiring one another. How romantic between these two. Require one another for the theory to make sense. According to superstring theory, the marriage of the laws of the large and the small is not only happy but inevitable. That's part of the good news. But superstring theory, string theory for short, takes this union one giant step further. For 3 decades, Einstein sought a unified theory of physics, one that would interweave all of nature's forces and material constituents within a single theoretical tapestry. He failed. Now, at the dawn of the new millennium, proponents of string theory claim that the threads of this elusive unified tapestry finally have been revealed. String theory has the potential to show